Hello everyone, today we're going to be working on problem 4-2, and this problem is asking us that in each case, so in case A and B, to determine the magnitude and direction of the moment of the force at A about point P. So as you can see here, we're going to start off with case A. So as you can see, case A, the 150-pound force that's acting at point A is diagonal. So how we already know that when it comes to diagonal forces, there is a vertical and a horizontal force to that. So what we're going to do is we're going to be finding that horizontal and vertical force, and then from there, finding the moment that those two forces are going to do about point P. You could solve for this all in one, or you could do it step by step. What we're gonna do is we're gonna solve for the forces first, and then from there we're gonna solve for the moment. So just to be able to find the y force of or the vertical force, we know that we could multiply the 150 pounds by 3 over 5. Since if we were to take a look at this like a triangle, we know that this side is 3, this side is 4, this side is 5, and we're trying to find the force of this side, which is the side of 3, and we're working with the side of 5. So we have 150 pounds times 3 over 5. And Q is in third. So 150 times 3 over 5. And that gives us a total of 90 pounds. So we know that vertical force has a force of 90 pounds. And since it's vertical, it either has to go upwards or downwards. And as you can see here, this force is going slanted downwards, which is why it's going to be 190 pounds acting downwards. Now to find the vertical, sorry, not the vertical, the horizontal force, we know that we can multiply that 150 pounds by 4 over 5, since now we're trying to find the horizontal force. So 150 times 4 over 5 is equal to 120 pounds. So we could have 120 pounds. Now, since this is a horizontal force, we know that it has to go either going to the left or going to the right. And as you can see, this is slanted to the left. So we have 120 pounds acting to the left, right? So now that we found that, now we're going to try to find um, the moment that these two forces are creating at about point P. So we have our vertical force. We're going to show it in blue. It's going down right here, right? And that's of 90 pounds, as we know. So from here, since this is a vertical force, we know that it has to shift to the right because since it's a vertical force, it has to align with this y-axis. So we have to shift it over here. So we need to remember, if you guys remember, that moment is equal to the force times the distance. So as you can see here, we already know that force, which is the 90 pounds that we know right here, right? So now we have to find that distance, and that distance is right here. But as you can see, it's not given to us. What is given to us though is, as you can see, with our force and this side, it creates a triangle. And we know that this side of the triangle has a length of 8 feet. We are given that this angle is 30 degrees. So we're going to use that to help us find that distance. So to find the length or the distance from this force to here, we've got to find this side of the triangle. So to find that side of the triangle, we are going to be using cosine. And why are we going to be using cosine? Because we are trying to find, with regards to this angle, we are trying to find this adjacent side of that triangle. And what's given to us is the hypotenuse side of the triangle. And we know that cosine is adjacent over hypotenuse. So here, distance is equal to that a feet times the cosine of 30 degrees. And that's what's going to give us this distance right here, right? Now, we're going to try to find the distance for our horizontal force. So our horizontal force is, in a way, it's coming right here and it's going straight up, right? And since it's a horizontal force, we know that our horizontal force has to align with our x-axis. So for this one, instead of our distance being like from here to here, our distance now is going to be this right here. So once again, we could use that this side is 8 feet long, that this side is that the angle is 30 degrees. But now instead of finding this side of the triangle, we are trying to find the length of this side of the triangle right here. And since we're trying to find the opposite side with regards to this angle, the opposite side of the triangle, and again, we're using that hypotenuse side that's given to us. This time we're going to be using sine because sine is opposite over hypotenuse. So for the vertical, sorry, not for the vertical, for the horizontal force, the distance is going to be equal to that 8 feet times that sine of 30 degrees, right? So now we're going to put this all together to be able to find that moment about point P. So we know that counterclockwise is positive. So the moment about point P is equal to, okay, now we're going to look if this is going to be creating a positive or a negative moment. So we know that our vertical force is acting downwards, right? So if we have this downward force about point P, acting about point P, we know that it's going to create a counterclockwise moment, which means it's going to be positive, right? So we have a positive. That's going to be a positive. It's going to be creating a positive moment. So once again, remember that the moment is the force times the distance. So we are working with our vertical component, our vertical force, and we know that our vertical force has a force of 90 pounds. So we have 90 pounds times our distance, and remember our distance for our vertical force equals 8 times cosine of that 30 degrees. Okay, so now we have our vertical component. Now we're going to do the same thing, but now for our horizontal component. So first start off to see if our horizontal component is going to be creating a negative or a positive moment. As you could see, our moment is acting to the left. So with regards to the moment about point P, since it's going to the left, we could see that that's going to be creating a counterclockwise moment. Once again, meaning it's going to be positive. Now, if it was going to the right, you could see that was going to create a clockwise moment, that would have been negative. But since it's going to the left and we're doing this about point P, we could see that's going to be creating a counterclockwise moment. So that's positive. So we have a positive moment once again. Remember, moment is force times distance. Our force is of 120 pounds. So 120 pounds times our distance. We know that our distance is equal to 8 feet times sine of 30. So 8 feet times sine of 30 degrees. And now we just input that all into our calculator. And if we were to simplify this a bit downward, we could see that the moment about point P is equal to 90 pounds. If we were to input this into our calculator, we'd get that our distance is equal to 6.0 93 feet plus we have our 120 pounds. And if we were to input this into our calculator, we'd get that our distance is equal to 4 feet. So if we were to multiply and add that, this, if we were to multiply that, that equals 623.7 pound feet. And if we were to input this into our calculator, we'd get that that equals 480 pound feet. And then if we were to add that together, we'd get that the moment about point P is equal to 1,104 feet pounds going counterclockwise. Let's actually make this just a bit smaller. There we go. Going counterclockwise. And just like that, we were able to find the moment about point P for case A. So remember, it asked us to determine the magnitude and the direction. So our magnitude is of 1,104 feet pounds or pound feet. Yeah, pound feet. I don't know why I wrote feet pound. Pound feet. And our direction is that counterclockwise. So now we could proceed and move on to case B. We're gonna move that over just so we could work on place where there's space to work on. There we go. Okay, so now we're going to work on case B. And as you can see, for case B, we have this 500 newtons right here. And we are trying to find, once again, the moment and the direction about it that it's going to be doing, but about point P, which is way over here. We have our point A right here, point P here. Once again, as you can see, we have this diagonal force right here. So remember, this will have a vertical and horizontal component to it. So simple to be able to find for that. We know that, hold on, okay, yeah. So once again, we're going to try to find that horizontal and vertical component to it. As you can see, it's given to us that our force is of 500 newtons and that this angle right here is 45 degrees. So if we were to draw a triangle right here, that's a triangle right here, we know that this angle is 45 degrees. So we're going to start off by finding, I guess, our vertical component to it, to this force. So we're trying to find this side of the triangle. We're trying to find the force of this side of the triangle. We are given the force of this side of the triangle, and we're working with this angle. So with the with with regards to this angle, we are trying to find the opposite side of that angle, and we're working with that hypotenuse side, which is why we're going to be using cosine to find that. Since cosine is, once again, sorry, we're going to be using sine, since sine is opposite over hypotenuse for the vertical component. So we have 500, that's a bit too big. Okay. So we have 500 newtons times, for the vertical component, we're going to be multiplying that by sine of 45. Once again, why sine? because sine is opposite over hypotenuse, and we're trying to find the opposite side of that angle, and we're working, or we know that hypotenuse side, which is y. So this is for our vertical force, and if we were to input that into our calculator, we would get 353.55 newtons. Now, for our horizontal component, once again, we are given this is 500 newtons, but now we're going to be trying to find this side of that triangle. So with regards to this angle, we are now trying to find the adjacent side, and we're dealing with our hypotenuse side. So this time, instead of multiplying it by sine, we're going to be multiplying it by cosine of 45, since cosine is adjacent over hypotenuse. But since it's 45 degrees, we know that it's going to come out to the same value. Just because it came out to the same value does not mean that in other examples or problems it's going to be coming out. It's really important to know why we're multiplying for our vertical, to find that vertical force with sine, and why our horizontal force is being multiplied by cosine. So once again, we get 353.55 newtons. Now we're going to try to find that moment that it's going to be creating about that point P. Um, You guys could leave it in newtons, but I'm just going to be dealing with kilonewtons just so our answer isn't that big. So I'm just gonna rewrite this in terms of kilonewtons. So that will equal 0.0035 kilonewtons. But you guys could still leave it in newtons if you guys want. I just put it into kilonewtons just so our answer in the end isn't too big. So now we're going to try to find the moment that is created about point P. So we know that counterclockwise is positive. So we're first going to start off with our vertical component. Once again, moment is equal to the force times the distance. We already have our force right here. Now we're going to try to find that distance. So as you can see, our point A right here is right here. P is right here. Something that we actually did not find is the sign, our sign convention. So our vertical force, we have to know if that's acting upwards or downwards. As you could see, this 500 newtons is going flat, like slanted upwards. So that's going to be going upwards. That's a positive 353.55 newtons. And for our horizontal force, as you can see, that's slanted to the left. That's why that force is going to the left. Okay. Now that we know our sign conventions, once again, we're going to work with our vertical force right now. So we know that force is going upwards, right? So we have a vertical force right here, right? That's our vertical force. So since this is a vertical force, we know it has to align to that axis where P lands on. So since we're trying to align it right here, we know that we have to shift this either left or right. As you can see, obviously, in this problem, we have to shift it to the left so it could align to that axis of P. So our distance is going to be all of this. And as you can see, you know that from our force to this y-axis, we have 4 meters. And from this y-axis to our point P, we know that's 5 meters. So that's going to be a total of 9 meters. So our distance here is 9 meters. Now we just have to figure out if that's going to create a positive or a negative moment. So if we were to, about point P, apply an upwards force, we know that that's going to be creating a counterclockwise moment, which is why it's going to be positive. Now, if it was going downwards, that force going downwards, it would be creating a clockwise moment, but it's not. This is an upwards force, so it's going to be positive. So positive, right? Our force, we said, is equal to 0.0035 kilonewtons times our distance. Remember, we said that it was 4 meters plus the 5 meters, which is a total of 9 meters. Okay, now we're going to work with our horizontal force. Our horizontal force, we know that we said it's going to be acting to the left. It's going to the left. So since this is a horizontal force, we know that has to align with that P to the horizontal axis of that P. So since our force is up here, we know we have to be shifting that downwards. So our distance is going to be this length. As you can see, our horizontal force to our x-axis has a distance of 1 meter, and then from there, our x-axis to that point P has a distance of 6 meters. So our total distance is 7 meters. So we do the 6 meters plus the 1 meter. So that's a total distance of 7 meters. Now we have to figure out if that's going to be creating a positive or a negative moment. So this is a force that's going to the left, right? If we were to apply a force going to the left on P, we know that that's going to be creating, once again, a positive moment. If it was going to the right, you could see that that would have been creating a clockwise moment. That would have been negative. But since it's going to the left, that's creating a counterclockwise moment. So once again, it's going to be positive. Our force is the 0.0035 kilonewtons. And we said our distance is equal to the 7 meters. And once you input that into your calculator, you get that this is equal to 0.0245 kilonewton meters. And this is equal to 0.0315 kilonewton meters. So if you were to add that all together, you would get that the moment about point P is equal to 5, sorry, no, I'm so sorry, you guys. Just give me 1 second. Plus 0.0315 is equal to, that was the answer if you were still working with it in newtons, but we have it in kilonewtons. You would get a total of 0.056 kilonewton meters going counterclockwise. If you were still working with this problem in newtons, you would get the same thing, just in newtons, so 5.66 Newton meters, also going counterclockwise. So we're all done with this case, case B. So once again, it asked us to determine the force and the direction. Our magnitude, our magnitude was the 0.056 kilonewton meters, or our 5.66 Newton meters. And remember that our direction was the counterclockwise.